Hello, can you hear me?
Yeah. Hey, hey, how are you?
Yeah, I can hear you clearly. How are you doing?
Yeah, I'm doing good, thank you. How are you doing?
Great, thank you. Um, so before we get started, I wanted to ask you a few questions just to make
Mm-hmm.
sure I give you the right kind of interview.
Mm-hmm.
Is this the first time that you're using interviewing.io?
No, I have been using it like this month, last month.
Okay. And what position are you interviewing for?
So I'm interviewing for a software engineering position. So I have an interview coming up at Facebook next week.
And what level are you interviewing for?
I'll be interviewing at the E4 level.
Is that a entry-level software engineer or is it like a mid-level?
It's mid-level, like next to the entry level position, which is ST2 position kind of.
Okay. And how prepared do you think you are?
I think I'm prepared, but yeah,
Yeah.
I've been
Okay.
preparing for last month.
Okay, fair enough. And so you're interviewing with Facebook next week. Are you also interviewing with any other companies, or are you interested in other companies?
Uh, yeah, I'm applying in other companies, but that is the only thing that is like set right now in the schedule.
Okay. So what I would like to do today then is the kind of interview we'll do is typical, maybe not for Facebook, but for other companies. Maybe for Facebook is each each on-site interview that you have will probably be 1 hour long, and it'll be a mixture of behavioral and technical questions. And so at the company that I work for, we give two behavioral questions, and each one lasts 10 minutes. And then we give one technical question, it lasts about 35 minutes, and then we leave time at the end for you to ask questions. So for you today, I'm going to
Mhm.
give you one technical question, and then I'll make a note of when 35 minutes is finished, but we'll just keep going afterwards and just keep doing the question.
Okay.
Okay. And if you hear me typing in the background, I'm just typing notes. I apologize for the noise.
I understand.
Cool. So what I'm going to do is also at the company that I work for, and probably at Facebook interviews too, the interviewing.io environment lets you run code, but
Mm-hmm.
when you interview at these companies, you will probably not have the ability to run code. And on top of that, when you're doing the interviewer is looking for you to try and demonstrate that your code is correct by walking through it manually.
Yeah,
This is
yeah,
like
I
a key
understand.
part. So you can feel free to use C++, that's fine. But what I'm going to do very quickly is turn it back to plain text, put the
Mm-hmm.
description of the problem, and I'll put it back to C++. That way the problem description will be commented out. You'll see what I mean.
Okay.
So I'm going to put it here. I'll put it back to C++ for you. And so, that didn't quite work. Oh, it's because I use C type commenting. Okay, I'll do this. 1 second. Oops. Wow. I am just changing the way I format my comments to be more compatible with C++.
Yeah, sure.
Here we go. Yeah. And so, yeah, just please read through the problem and let me know if you have any questions.
Okay. Online retailer is releasing a new feature called "What Are My Friends Buying?" The feature lists a set of products that you have not already purchased from the things that your friends have bought, in order of most bought to least bought. To help with this, we have the following two APIs: complete the function that it takes in a person and return the item that the person's friends are buying. Okay, so we have a new feature called "What Are My Friends Buying?" and this. Okay, I think let me write out my thought process here.
Okay.
Okay, so we are trying to release a new feature that is "What Are My Friends Buying?" That means we want to get the list of products that someone's friends are buying.
Mm-hmm.
Okay. The feature list is a set of products that you have not already purchased. That means the recommended products are not bought by the person that we are asking for the list.
Mm-hmm.
By the current person. Okay. So these are the products that his friends are buying, but it is not in that something that person has bought. And the things that your friends have bought, and in order of most bought to least bought. Okay. So the return list
Mm-hmm.
should be sorted by frequency from high to low.
Mm-hmm.
Okay. To help with this, we have the following two APIs complete. Okay, so we have two APIs where we get purchases. Okay, so we give a person class and then it will return the purchases. Okay, yeah, that we definitely need. That API is given a person, we want a list of products that that person purchased, and the second API is given a person, we want we want to know the friend list of the person.
Mm-hmm.
So this is essentially this will return product list, and this will return the friend list.
Mm-hmm.
Okay, so now I have the question sorted out. So the ask here is complete the function that it takes in a person. Okay, so there is a person class and returns the items that the person's friends are buying. Okay, which is sorted in high to low frequency.
Mm-hmm.
Okay, that means you have to write a function which will list a number of items. Okay, maybe I'll call this some string of items. So I'm just assuming that the items, product items, will be some string in the form of a string, like the name of the item.
So no. So like the APIs return actual classes with a name or with a type capital I item, and then there's a capital P person.
Okay. Okay. So this will return a vector of items, and this is completed as well returns the items that persons are buying. Okay. So this may be recommended products, and here we need the input for the person whom you want this list. Yeah. So this should be the function signature look like. Okay, so before I start, so I just want to clarify some constraints. So how many number of items I need to return in the recommended products?
All of them that meet the problem description.
Okay, so there is no fixed number, so I should return everything from the friend list, whatever is not there in the person's like purchase list.
Mm-hmm. Yes.
Okay. So please return all items that are purchased by friends. Okay. 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 Let me start with one example so that it will be clear.
Mm-hmm.
Maybe person A has three friends, it is B, C, and D, and products bought by each person. So products bought by person A is suppose some item 0, 1, 2, 3, and product purchased by person B is maybe 3, 4, 5, 6, and C is 7, 8, 9, and 0. And okay, let's limit it to this number. Okay, suppose I have two friends, and these are the products they have brought. Then once I call the function, it should return for person A. It should return that 0 is on. So these are the things I have already purchased. That means 3 I have already purchased. So 4, 5, and 6. So 4, 5, and 6, and 7, 8, and 9. Okay, so this should be the answer, but we want it to be sorted from high frequency, like by frequency from high to low, and the frequency will depend on like how many persons have actually purchased that particular product, right?
Yep.
Okay. Okay, so for data structures, first I need to have a data structure to store. Okay, so the API I have, it will return the list of products. That is in the form of a list. Okay, but I want to check whether all those products are bought by other persons or not. So I should use a dictionary here to store items. And for each person, I am getting a list of friends. Okay, and for each friend, I can query all the products they have purchased. Okay, that means I need to. Okay, that means I need to get for each person, I will get its friend list. Okay, so person A, first query the friend list. So it will return B and C, and for each person in that list, I have to query the products. Okay. But I have to sort it by frequency. That means for each product, I have to know that how many persons have bought that product. Okay. So I need another data structure where I should store the persons, like for each of the products, how many persons have bought that product. Okay. Okay, let's say that this is a dictionary to store mapping of item to person. And this will be the count of person. So this way I will know that, okay, the product 0 has been bought 2 times, product 3 has been bought by 2 people, and like this. Okay, so this will help me in storing the frequency wise. Okay, so once I have this, then I should sort it based on the frequency.
So just to be clear, on lines 26 to 28, the get purchases API can return multiple items if a person has purchased it multiple times.
Okay, sorry, I missed this. Return a list items. If you purchased multiple items, an item will be in the list multiple times. Okay, if the item is in the list, that means if it is like 6 again, and this is like 7 again. Okay. So this won't be counted. So the question asks that Most bought to list. So this most bought is only the criteria is like the number of different person, right? Not the same person.
No, it's purely the number of times it's purchased, regardless of who's doing the purchasing.
Okay. So this is does not matter like whether the same person is buying that product multiple times.
Yes.
Okay, so it is simply the count of purchases instead of persons. Okay, so I have to store this count of purchases and item. Okay, so let me think. So first I query the person, its friend list, and for each of the friend list, I get all the products, and for all those products, I store it. I map it to that product like item to the count of purchases. So this way, I have suppose product 0 is purchased 2 times, product 3 is purchased 2 times, product 7, product 0 is purchased 3 times, sorry. Product 3 is purchased 2 times, okay, like this. So this dictionary should look like this. This is mapping of item to count. Okay, so once I have built this count, that means I have to go through each of the like the current person and all its friends and create this mapping. Okay, so once I have this mapping and I store in the first dictionary, I just store the items that the current person has purchased. So this will be a unique list of items that current person has purchased. Okay, so then I can go through this. Okay, so I can go through the entire list of items. Okay, this one, the second dictionary, where I have count like mapping of each item to count. And if any of these items are present in the first dictionary, that means for the current person, I should avoid that. I should just skip that one and keep on returning the other ones. Okay, so this part now I am clear that how I can return the items. So now I think I'll go back to the question, how do I sort it from high to low frequency? Okay, so for sorting it from high to low frequency, instead of, okay, once I build this dictionary, I can put it all these items as a pair, maybe in a priority queue or like a heap data structure. So that way, I will put the highest here. So what the third will be to use a priority queue where I store a pair with count and item ID. So this way, and I store it from maximum like high count to low count. So all these items based on their count will all be sorted. So this will keep it sorted from high to low count, like sorted based on frequency. Okay, so once I have this, then I have to keep popping each of the items like top of the priority queue. And if that item is in the first dictionary for the current person that has purchased the item, then I should skip that. And all others I should just return. Yeah. So this way I will, so the returned items will be sorted from high frequency to low frequency. And I will skip the items that the current person, the user, like the person that is passed to the function, that I will skip. Yeah. Okay, so now I have the thought process, like how to solve this. Maybe before I write the code, I want to go through the time and space complexity of the problem, the solution. Okay, so the dictionary. So first, I will be using a dictionary to store the items. That means if the current person, that means I will be going through all the friends and I will be going through all the items they have purchased. So if if n be the total friends
Mhm.
and m be the total number of items purchased by person and friends, like including. So I'll be going through this whole list and I will store it in the priority queue for each item. Okay, so maybe let's see U be the unique number of items purchased by that are there in the for all the users.
Mhm.
And for those many items I am using a priority queue. So that will be okay. So initially this will be n plus m just to store get all these values for the dictionary, like populate all this data structure. And then once I have the unique number of items, so those many items to build this, it will take u time. But once I start popping each of the items, so it will be u log u. So this is the time I will take. This will be the entire time. Yeah, this will be the time for the whole algorithm. And for space, and here I am assuming that I am not accounting for the call to this API because that is a kind of unknown to me, like how much time it takes to get the friends or purchases. Can you hear me?
I'm sorry, could you repeat the question?
Sorry. So I think that here I'm not accounting, I'm accounting that this get friends API and get purchases API is kind of constant time for me.
Oh, yeah, that's fine. You can assume that.
Yeah. And space complexity will be, I am storing the items for the current person. And I'm storing the items. So for all the unique items, I'm storing the count. And those one, I'm also storing the count in the priority queue. So this will be u plus u. And the output will be, yeah, that will also be order of u. So this will be order of u. So this is order of n plus m. And log u. So this is essentially, yeah, this should be the final time and space complexity.
Okay.
Okay, so if you're fine, then should I start coding now?
Yes, please.
Okay. Okay, I think before I start, I have one question. Is that this item and person, these are some classes. So how do I store it in a dictionary? So can I create some kind of, can I query some kind of ID or something for this item class and person class?
Ash, you can either query an ID or you can assume it can be inserted into a dictionary as a key.
Okay. Then it's fine. Okay, so the function signature is here. these are the two APIs I have. So my first step is to get the items. I will store it in a dictionary here. Okay, let's say call it item, and this is the purchased list. So this is already purchased by the person. So for each item purchased by the person, so that is get purchases by this current person. It means all the items that the current person purchased, I will just put it into this dictionary, which will store only the unique items. Okay. So this is step 1. Then step 2 is to get all the friend list and for each of and query each of their items. Okay, so before this, I should also create the dictionary which stores the mapping of item to count of the number of purchases. So this will be another map of item to integer for the number of count. So this is item to count mapping. And for the current person also, I should add the items count. So item to count of this current item is +1. Now I need to get the friend list, and for each of the friends, I need to get all the items they have purchased. And for each of the friend, for each of the friend in the person's friend list, that is the API is create friends person. Okay, so now I have each of the friends, and for each of the friends, I need to get all the items they have purchased. That is auto item for get purchases for the friend. Okay, for each of the friend in the friend list, I get all the items here and I update the count here. So item to count of that particular item is +1. Okay, so now I have the step 2 done. So now the step 3 will be to create a priority queue. So I create a priority queue where I store a pair of first will be the count and second will be the item. So this is the max priority queue. As it is a pair, I do not have to write the custom function because it will, by default, it will use the first element of the pair to compare.
Okay.
And here I have to go through all the elements in the item to count list. Max queue dot push. So it's e dot second, that is second is the count for the item, and e dot first is the item's ID. Okay, now I have to return a result. So result will be in form of a vector, And in this, I need to push, okay, I need to return all the elements that are there in the priority queue, which are not in the current person's purchase list. So I will go through this while loop until the queue is empty. And if auto current item is max queue dot top dot second, so that is the item ID. So if this item is purchased, that means if purchased dot count, so that means if it exists in the dictionary, that then skip. That means if it is not exist in the dictionary, okay, if it is not purchased by the current person, then we push it into the result. Otherwise, yeah, and we pop the queue. Yes, I have the code, complete code. And I think let's go through this example.
Great. Okay.
I just copy this example here so that it will be easy to follow. Maybe just change some values here. Okay, let's make this 3, make this 6, this one maybe 4. Okay, so we just declare this dictionary here, then we declare another dictionary to store the purchased items. So first okay, so we are querying for the person A. That means this function is calling person A here. And for the person A, we will first query the purchases that that person made. So the purchases, it will return 0, 1, 2, 3. Maybe I will make it one more here. Let's make it 0. So it will return all these numbers here. And for each of these items, that means 0, 1, 2, 3, 0, it will increase the count for each of the items. That means at end of this step, the dictionary will look like 0 has count of 2, 1 has count of 1, 2 has count of 1, and 3 has count of 1. And as this purchase dictionary is storing only the unique items, so this will have items 0, 1, 2, and 3 in any arbitrary order.
Sure.
And in the step 2, I call the friends of person A. So friends of person A, it will return B and C. And for each of the items the person purchased. Okay, so let's first do it for B. So for B, it will return 3, 4, 5, 6, and 6. That means the dictionary will become, so this was the previous state, and I will add the count for 3 to 2, count for 4 will become 1, count for 5 will be 1, and count for 6 will be 2. This is for B, and the next friend is C, and for C, we'll return the purchases that are 7, 3, 4, 0, and 7. So here we already have 3, so 3's count becomes 3, 4 count becomes 2, 0's count becomes 3, and 7's count is 2. So there are 2 7's here. Okay, so this is a dictionary. Now we want to push all these items into the priority queue. So priority queue will have 0, 1, 2, 3, 4, 5, 6, 7. And here the highest count is for 0 and 3. So it will be 3, 0, then 3, 3, then 4, 6, and 2. So 4, 2, sorry, 2, 4, 2, 6, and 2, 7. So we have 3 to 5 items. Then the remaining have count of 1. So that is 1, 2, and 5. So this is 1, 2, and 5. Okay, so this is the priority queue. And here we come to the result. In the result part, we go through each of the items. That means first it will be 3. And so initially in this list, we have 0, 1, 2, 3. I'll just copy this here. So this is the purchased list of the first item in the priority queue will be item 0, which has frequency of 3, and 0 is already there, so it won't be pushed into the result. Then it is item 3. The 3 is also there, so it won't be pushed into the result. Then item 2, it is also there. Then item 0, 3, and then it is 4. Sorry, this is item 4. That means the result will first be pushed 4 here, 0, 3, 4, and then item 6, then item 7, 2 is already there, 1 is already there. So this will finally return 4, 6, and 7.
Cool. I agree. I had a few clarifying questions. Thank you for walking through the code. But going back up to line 74, when you determine the time complexity, so let's only focus on the U for a second. Unique number of items you're using a priority queue. What again was U plus U log U?
So the initial U is to build the priority queue. So this is the building part.
So is it OU time to build a priority queue?
To build a heap of n items, yeah, it takes order of n.
No, I believe it takes n log n to build a priority queue, unless the input is sorted.
Maybe
so
this.
Each push requires a rebalance of the heap, which is log n.
Yeah, each function takes log n, but initially, because you will be starting 1, 2, 3, and finally going till n. So this means initially the log value is not actually log n, right? This will be something much lower than log n because the number of items are less. I exactly don't know how the priority queue works, but if it is a heap, then it will be directly like only order of n. So this is guaranteed. I have to check like how this one works.
That's fine. I believe that it's n log n to construct unless you have an ordered input. So I'll leave a link in your comments and you can take a look at it later. So let's move on from that. So now we're at the end of the time. So this is 35 minutes. So what I wanted to do is just give you some feedback initially, and then we can keep on going with problem.
Okay.
So yeah, this was you gave a very good response, and you were very careful in clarifying the requirements, and you gave the good time and space complexity descriptions. You wrote code that I agree that it works, and you stepped through it with an example. So you gave a good response. I think my only feedback for you is that initially when you were, I think it's on lines 34 to 40, I think you were, when you're clarifying the problem, you don't need to type it out again. So I think where you started on line 42 with the method signature is great, but just typing out the problem again, I think it took you 4 or 5 minutes, and I think you could have saved yourself 4 or 5 minutes. The reason why I say that is because interviewers typically, like me, we always
Mm-hmm.
reserve some extension questions for the candidate. And once you have
Mm-hmm.
code, then it's much easier to reach the extension question without with actual code as well. So ultimately, you're only evaluated on the code that you write down. But I also evaluate you on your problem-solving abilities. But I think you don't need to write it out again, lines 34 to 40. Do you find
Okay.
that's helpful to you when you do that?
Uh, I just wanted clarity like what exactly I'm going to do, but yeah, that took 5 to 6 minutes, I think, easily.
I think you, but your clarification of the problem was excellent. I just think that you could do that verbally and just start at
Okay.
line 43. Always give the method signature, but you can just start. You can first clarify verbally, engage me in a conversation, and then just go ahead and clarify with a method signature.
Okay. Okay. Yeah, I'll keep that in mind.
Cool. And also with the priority queue stuff, you
Mhm.
know, I wouldn't worry about it too much. But something I wanted to ask you is there an alternative to using a priority queue in this for steps 3 and 4?
Instead of priority queue, I can use a like a set that is a like a balanced BST in C++. So that is a map. So that
What would
will
you be
also
mapping?
I'll be I will have so it will be on order. So actually, no, it won't be a map. It will be a set with the
Okay,
same pairs, which has
set with the same pairs. Oh, and an ordered set with the same pairs.
yeah, but this will be as yeah, but the time complexity value should be exactly same as
Yep,
inserting and deleting is
yep,
also same login.
I agree. I can see how that would work. Also, something else to consider is what if you could you use sorting to solve steps 3 and 4?
Uh, yes, I can do sorting. Yes, if this step actually if this step is login, like when login actually to build a priority queue,
Hmm.
then we can very well like get away with sorting so that it is in login and then I know the order of the items directly
Yep.
stored in a like a
But,
list, the
but even
vector
if
or
even if the priority queue, let's suppose it was on to construct. We both agree that in order to retrieve the items is n log n to retrieve. So in the end,
yeah.
all these solutions are equivalent.
Yes, yes, yeah, that's
Cool.
correct. Yeah, even if I don't use for yeah, for a list
Yep.
and sorting also it will give yeah, the ultimate time complexity will be same.
Cool. Um, these are all questions that I would like to ask you during the interview. So during the interview, I would probably interrupt you while you're doing your example, so I could ask you these questions because this is part of my evaluation criteria.
Okay.
So here's just a very basic question. It's like, why did you choose unordered map and unordered set as data structures?
So these will have average constant time access time.
And
If I
how are they
use
implemented in C++?
so in C++, they have I think some kind of hash function to implement all this unordered map and set.
Mm-hmm.
But in if I use the regular map and set, that is essentially a self-balancing binary search tree, so which
Mm-hmm.
each of the operations are guaranteed to be logarithmic timing.
Okay, great. So what I'd like to do is give you the extension to the question I would give to a candidate. So,
Mhm.
and then we'll just keep going until our hour is over. Does that sound good?
Okay. Yeah.
Cool. Let's just do it. So just to be clear, you met the bar for this question, but in future, try to maybe exclude the typing out of the problem description so you can reach this
Yeah.
extension. I'm gonna
Yeah.
put this
Yeah.
onto, I'll put this onto line 33. If you want to copy paste your code or whatever, that's okay, but I'm gonna put it on line 33.
So instead of your friends, what about your social circle? The social circle of a person is defined as the person's friends and their friends. Okay. Okay, so that means, okay, sorry. That means if I have friends, A has friends B, C, and D. B has friends E, F, and maybe D. Then we want to get all the list of items that all the friend circles have purchased. So, I think before I think through us, I think first question that comes to my mind is, so if A is a friend of B, is it like mutual friendship, like B is also friend of A, or it is only one direction?
That's a
That
good question.
that means if A is
So,
friend of B, yeah.
yep. Mhm. So it may or may not be true. Sometimes B could be friends with A, sometimes B might not be friends with
Okay. Because if it is a mutual friendship, then the problem essentially comes down to finding the connected components in a undirected graph. Because all this, so A will be the node, and this is the friend list will be the edges which are connecting from A to B, A to C, and A to D.
A. Hmm.
Similarly, for each of the person, if I take it as a node in a graph, and all the friend list will be each of the edges.
Hmm.
And if it's a mutual friendship, then essentially I have to find the connected component in an undirected graph. And to find that, I can use like either bid first search or depth first search. That means start with any one of the person.
So I agree that in general, if you want to find directed components, you can give an algorithm. But remember, our problem statement is we start with a person. We know we're starting with ourselves.
Okay, yeah.
I agree in the general context, but very
Mhm.
specifically, this is like a retail website. It's just ourselves. We know we're always starting with A.
Okay. Yes. So if we are starting with A, that means we have to keep on exploring all the friends.
Hmm.
But so then it is simpler in the sense that we just have to keep a like a unique list. So that is essentially a dictionary
Hmm.
where we keep on. So for each of the friends, we call. Okay, but then it yeah, it will be might kind of form a loop. So there should be some kind of data structure where we know that what all friends we have already visited.
Okay.
Yeah, so this I think the same list we can use the same dictionary, and
Okay.
here we keep on putting. That means we start with A here, and if it has friend B, C, D, that means the dictionary now has A, B, C, and D. And next we explore for B, and B has E, F, and D. So E, F, D is already D is not already explored. D has to be explored after next. So this will be this will be essentially a depth first search starting from A, and whenever I find friends for like each of the friends, then I'll keep putting in a unique list.
Hmm.
Yeah, so this way that means my goal is to starting from A, I want to explore everything that is connected to A.
Yeah.
Yes, yeah, that's I think the goal here. Okay, so if I want to convert it into a code, I
Hmm.
just okay, let's see here. I'm just putting this comment in the bottom.
Okay.
Okay, so I want to explore each of these friends here. Because instead of just going through the friends of the current person, I should be exploring everything. That means suppose I have another function to do that. that is get friend circle, and this will have a input of person, and I'll have a data structure, a list of persons. Circle, and here if the person is okay, if the person is already okay, that means if the person is already explored, then we don't need to explore. So if it is already there, then just return, else add the person to the circle, and for each of the friends of that person, explore all the explore all their friends. Yes, so this will essentially populate all the friends, like all the friends in the circle of that person in this particular dictionary.
Mm-hmm.
And once this part is populated, that means if I do here, so instead of doing this, I should be doing in the step 2, I should be.
Before you use it, so just speaking about the method you created. So the problem statement was a social circle of a person is defined as a person's friends and their friends.
Yes.
So does your method meet that problem statement?
So this will actually, I have to clarify that this is something that is, if I'm using a class, so this is kind of a class variable, or I have to.
That's fine. That's fine.
Yeah, or I have to like pass the reference to this because this is constantly modified.
So suppose in your example, A is friends with BCD and B is friends with EFD. I'm going to type in line 155. Suppose F is friends with GHI. I won't go too far. So the problem statement is I only want to see the friends of BCD. I don't want to see GHI or Z. Does that make sense?
So it is only that means one level down.
Mm-hmm.
It's not going to be all the friends of friends of friends and friends.
Mm-hmm.
Okay, I think I misunderstood the question then. I think I thought that this is friends of friends of friends. Okay, so this is only
also, like,
finding.
it could be pretty risky if you keep going with all the. Imagine on Facebook, if you just kept going with all the friends and all the friends, you would probably pull the whole graph. That would be pretty.
Yeah, that's true. That will be some billion people. Yeah. If it is only one layer of friends.
Yep. How would you modify it to handle one layer?
Then it will be just so instead of going through this where I recursively calling that function, so I have to for each of the friend, then I have to call the friends. That means for here I have to call for each of the friends. That means maybe friend 2.
Yeah, you could do that. But what if then I extended the problem and said, no, I don't want just friends of friends. I want n levels.
Okay. Yeah, that's true. That means I need to explore only till certain level. So then I think it will be a good idea to use breadth first search. where I limit my distance to n. Since if I have to find up to n level of friends, then I explore only till n level. So instead of this function, I should be using a breadth first search where like I start with A and A has nodes B, C, and D. So this will be a level order traversal. That means at each level I explore all the friends. So that is like one level, and then keep on increasing how many levels I want. That means for the initial problem statements, it will be distance will be 2. That means A is all friends, and then those friends next level friends. So can I just write I think the core algorithm. So if I start with, I have a queue, and queue initially has, so queue initially has person A, and I say until queue is empty, and here I define the labels. Suppose I have label of something n, and then I do queue size -1, I greater than equal to 0, minus I. So all the friends that are there in the current label and explore all their friends essentially. That means for so queue is not empty and n is greater than 0, and for each label I'll reduce the n to n by -1. It's all of the friends of the current person, so that person will be the queue's top item, and here I do queue pop, and for each friend in get friends of that person, I keep on adding those to the queue. Yeah. So this way I'll just stop at how many labels I have defined, and essentially, actually one thing I missed here is whenever I am popping the item, so that person has to go into the dictionary where I have like a list of unique friends. So this will essentially go to the circle where I insert the person. That means at the end of n iterations, I will have all the friends of the person starting with A. And that I can then use, that means at line, okay, so this I do not need. That means at line 119, when I was calling the get friends for the particular person, I should be iterating over all the persons that are there in the circle, that is in the dictionary, which has all the friends.
Perfect. Yeah, you don't need to write the code. I understand what you did with the BFS, and you could put it inside get friend circle, and you can use it there. So yeah, just because we have 1 minute left, yeah, what I would say is for this question, when an interviewer poses an extension to the problem, you solved it correctly, but be careful that you, I don't know, like try to find, you correctly made a helper method in line 143, but then when I clarified the question, said, oh, it's only one level, then you started ignoring your helper function and you just started editing the code on line 119. I think your use of the helper function was excellent, but like because the way this interview would go is you'd make a helper function, it only handles one level, and then I would say, oh, what about n? You would say, oh, you want to handle n? You just, all you have to do is change the helper method. You don't have to change your core logic and recommended products.
Yeah, I think this function was not suitable for that particular approach because I wanted to change to BFS now because initially I was started with BFS.
You could do, yeah, but it's something else to
Okay.
consider. If you really wanted to use recursion, which is fine, you could easily have the recursive call accept an integer parameter, and you just decrement it when you use the recursive call, and then you can just stop
Yes.
when you hit 0. If
Yeah.
you if
Or I
you
can
wanted
just
to use,
change the function.
yeah. So like using helper methods is it was great. That's a great instinct. That's something that people look for mid-level SDEs. So try not like once you have working code, the recommended parts. Look, it's already so complicated. You don't want to like keep adding more to it. You want to try and refactor it out into separate methods.
Yes. Yes. Yeah, that makes sense.
Cool. So this is an hour, so we're out of time. But do you have any questions for me?
I just want like how was the communication from my side? Like were you able to understand everything or like I was not clear at some parts?
No, your communication was very clear. You use the text editor in a very good way, especially when you're going through examples. Your technique is excellent. So you don't need to you don't go into too much detail, but you have enough detail. So like for example, line 121, when you're telling me what's inside the item count dictionary or map, I understand. So your communication is good. Um, it, Different interviewers have different requirements, but you don't need to start with time and space complexities. You can end with it if you want to. So you don't need to
Okay.
get bogged down in it too much because sometimes what will happen is this happens a lot. As you write an answer to the question, you realize, oh, I got something wrong. Oh, I forgot to do this, and then you do this. And so that's why if you first write the code, um,
Mhm.
then you do time and space complexity. There's less risk that you have to go back and fix it up.
And also, I think I have more chance to finish the code.
Yeah,
Mhm.
for better or worse, I misspoke. The code is not the only thing that you're evaluated on. For this question, actually, I'm evaluating you on your use of data structures and algorithms, and you did very well. But I need code. Um, the code is not optional, but the written everything else is optional. But for this question, time and space complexity is not optional. I just think on average, if you do it after the code, there'll be less need to go back and fix it up.
Yeah, yeah, I think that makes sense. Yes.
Um, yeah. Otherwise, yeah, this was all great. Do you have any other questions for me?
I think yeah, I'm good. Thank you.
I'll give you one other extension to the problem, which is not difficult, but if you want to do it,
Yes.
try it out. I'll post this on line 47. Um, um, Not difficult, but the code is not difficult, but maybe more interesting is how does this change the time complexity? It's perhaps more interesting.
Okay.
Yeah,
Yeah.
try it out.
Yeah.
After try it out afterwards. But yeah, that's all for this interview. So thank you for your time.
Yeah. Thank you. Thank you for your time.
If you want to copy paste this stuff, feel free to copy paste it now.
Uh, will this go away? I think it should be there in the
It'll be there,
any.
and it'll be there in a video recording.
Yeah, I have copied it. Anyways.
Cool. All right. Thanks a lot.
Yeah. Thank you.
Okay. Bye.